All right, gang. Yeah, so real quick before we get started, I'm trying an experiment, and that is a completely unedited video. And I mean, I've gotten pretty good at just riffing at the camera and extemporaneously, blah 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 blah. And there's several other creators that I like that do this. And I know that some of you have said that you like the more unstructured rambles, and so we'll see how it goes. We'll see what the numbers do. But what I wanted to do was just kind of free associate about where things are at with artificial intelligence right now and just kind of the vibe check. So obviously I am more online than I would prefer to be for various reasons. Number one, just being that my physical energy is not where I would like it to be yet. But the good side of that is that I am dialed into what is going on out there. So there was the new DeepSeek paper that, if you haven't heard of it, what is it, the MHC? I don't remember the name of the architecture, but everyone is losing their minds over this new architecture. It has to do with attention mechanisms. I haven't read the paper, but I've been watching the vibe, and a lot of people are very excited because DeepSeek has repeatedly, and this is the most salient point, DeepSeek has repeatedly just demonstrated, hey, if we find more clever algorithms, we can get state-of-the-art performance with a tenth of the scale or less. They demonstrated near state-of-the-art performance with, I think it was like in the low 5-digit millions parameters. So like I think it was 20 million or 20 billion parameters, much smaller than the trillions of parameters that other large models have. So that's one thing that's going on. And then another thing that just popped up is recursive language models. That seems like it's the next big thing. There's been a handful of papers and some other stuff coming out where people are just very excited about, recursive language models. And I spend a lot less time on the technical nitty gritty than I used to, because at a certain point, there's what happens in the lab, and there's, the frontier papers, and that's all good. But really what happens is every single one of those dozens or hundreds of little insights that comes out every single week now, not one of them is a silver bullet. But what really happens is that they all get rolled up into the next generation. We're on Claude 4.5 and GPT 5.2. So in a couple months, all of these different innovations are going to be rolled up, and what ultimately happens is you see the frontier capability just keep getting to a tipping point. Now, the biggest thing, here's kind of looking at it from a different angle. Right now, the entire internet is losing its composure over Claude code. There's been a few tweets that have gone out, and other people just realizing that Claude code has gotten to a tipping point where even the leading developers in the world and the leading researchers in the world, and it's not just in coding and computer science, it's economists, it's law professors, it's all kinds of people are using Claude code for stuff other than code. So what that tells you is that the underlying engine, the cognitive engine, has gotten to a point where it is sophisticated enough that it is performing real cognitive offload. And so when we talk about cognitive offload, this is a term that I originally got from avionics, actually, from jet fighter theory, because the idea is that when fighter pilots' decisions come down to split-second decisions, you have to offload as much cognition to the machine as possible. So that means the avionics, the radar, everything else, and the pilot's attention is the most scarce resource. Now, treating attention as a scarce resource is also the design philosophy of Unix, which is basically if a command works, don't give any output unless the user specifically requests output. So you want to optimize around that. And so what this all started a couple of years ago when I was like, what is the future UX of AI? And I realized that cognitive offload, that is fundamentally what artificial intelligence does, is it allows you to get brain power back, where instead of doing the mental hard work of the low level stuff yourself, you become a supervisor or a manager and you just tell them what to do. Now, for most of 2025, we were getting to a point where, you could fire up a codex session and it would go, write some code, and it's like, cool, you wrote that function for me. All I had to do was be smart enough to specify the function and you could go write it for me, but you still had to know what to ask for, or at least be able to articulate the problem clearly enough. Same thing for like all the deep research tools where it's like, okay, I want to generate a report on this topic or solving this problem. Go do it for me. And it could generally get pretty good. But we've crossed the tipping point. So all of those different papers, whether it's attention mechanisms or agentic frameworks or tool use or MCP, whatever else, all of those are just low-level nitty-gritty. They have all been integrated into what Claude Code has become, and that has gotten to a useful tipping point, the utility tipping point. And what you've just seen is what's called a network effect. So a network effect in this context is when a new technology or a new process gets to a level of usefulness and sophistication that it seemingly goes viral. And so this is what I've been talking about for a long time when I talk about the automation cliff. So the automation cliff is basically automation doesn't do anything until it's good enough, and then suddenly you use it for everything. And historically, in my career as an automation engineer, you basically had to automate one solution at a time. Which is like, oh, hey, we need to set up a bunch of VLANs on this network or a bunch of data stores or migrate servers. You can automate each of those individual tasks, but it's a separate automation engine or a separate automation workflow for each of those individual tasks. However, what we're seeing is with tools like Notebook LM, which allows you to do a lot of automation and they keep adding more stuff. So that's one kind of automation, but it's a general purpose automation tool. And that's the key difference. What we're talking about, excuse me, is general purpose technologies, which is like the wheel. The wheel is a general purpose technology because you can put it on a cart. You can put it inside of gearing. There's all sorts of stuff that you can do with the wheel. Electricity, likewise, is the most versatile general purpose tool that we've ever created. And as an example, you can have lights, you can have cameras, and you can have artificial intelligence. There is no general purpose technology more general purpose than electricity. However, artificial intelligence is the next iteration of general purpose technologies, meaning that once you have the correct affordances, you can use Notebook LM for any kind of research task. It is a general purpose research automation tool. And they've even included, I don't know if you've used it recently, but you don't even need to upload documents. You can just go into the search bar and say like, search for this information, and it will go use Gemini to find the right information. So you don't even need to start outside of Notebook LM anymore. You can just start inside Notebook LM. And then of course it can do slide decks for you. It can do podcasts. It can do infographics. It can do charts, all kinds of fun stuff. And they're doing bilateral integration with Gemini. So it's like, it doesn't really matter which tool you're using anymore. Likewise, Claude Code seems to be at a tipping point where this is a tool that what I've seen, the most differentiating use cases I've seen for it is not just code, but data. And then when you integrate retrieval augmented generation and search and code and data execution, then you can do some really serious heavy duty stuff. And so like what kind of inspired this line of the conversation was there's an economist that I found just as his tweet was going viral. And he was talking about like, oh yeah, like I just said, I need this kind of data, and it goes and finds the data for you. And for any kind of rigorous scientific research, getting good data is always the hardest problem. And this mirrors what I have found in using these kinds of tools for my own research in post-labor economics, which is if you know what kind of information you need, these AIs are really good at finding that particular kind of information. You say, I need a historical example that demonstrates principle X, or I need data that supports or doesn't support principle Y. I need previous thinkers and other research papers and academics and quotations that make point Z. And so you just string all that together. And of course you might say like, well, the obvious problem there is you're in your own search bubble and you're also basically operationalizing confirmation bias, but you can do the opposite too. You can say, okay, this is what I believe. I believe X, Y, and Z principles about economics or biology or history or whatever the topic happens to be. And whether you're using Claude or Notebook LM or Gemini or whatever of these tools, you can then also say, well, is there any countervailing examples? And while I understand the human instinct to basically avoid, falsifying your own beliefs, it's really interesting because more often than not, if you do the due diligence of like looking for the countervailing points, then you'll often strengthen your own argument even better, because like negative examples are often more important than the positive examples. And so what I'm referring to is a very specific thing here, where when I was very early in my, AI career and I was doing cognitive architectures and that sort of thing, I was, you can study intelligence, you can study cognition, but if all you're doing is looking at a working brain and saying, how does that work? That's not going to give you the same kind of contrast that looking at broken brains does. And so one of the most interesting ways to understand weight, by virtue of looking at how cognition breaks, you can actually gain a lot more insight as to how it actually works. And so I read the work of V.S. Ramachandran, who studied things like phantom limb syndrome. And there's lots and lots of other neurological disorders that have just the weirdest effects. But those give you clues as to how the brain actually makes sense of reality, how the brain actually keeps track of tasks and task prosecution, and all that went into, all my work on the ACE framework and everything else. And if you're OG enough to remember the ACE framework and the Haas agent swarm and all that fun stuff, then I guess that was only a year or two ago. Some of it was 3 years ago. But anyways, so, and now what I like, when you use these tools, the affordances of these tools, like, yes, you can get yourself into an echo chamber, and some of the models are still very, very sycophantic. Gemini is by far the most sycophantic model out there still. If you have a belief and you keep saying, find evidence for this belief, find evidence for this belief, it'll just eventually just say, okay, cool, to the point that it will like look for the most sparse clues to confabulate a narrative that supports your views. And it's like, okay, it's one thing to have a tool that doesn't push back and doesn't lecture you too much, but it's another thing for a tool, because if you're mistaken, and I've had this happen a couple of times where there was something that I just didn't remember correctly, and I was like, no, like, I know what I'm talking about, help me find evidence for this, and it just eventually was just making stuff up, and I realized, you're just making stuff up. So I copied the whole conversation over to Claude, and I said, where did we go wrong? I said, I was like, am I making something up? Am I misremembering? And that sort of thing. But the fact that I knew to do that, and I have developed that as a value to say, okay, hold on, this machine is just agreeing with me everything that I say. And it's like, well, why, yes, that sounds like a great idea. And I'm like, no, something has gone horribly wrong here. So, and checking your work is, of course, like, and anyone from, with a scientific background or an academia background, I have a friend who has a hard time writing blogs and opinion pieces because she has such a strong academic background. She's like, I can't make any assertions unless there's evidence. And I'm like, the evidence is your feeling and your belief and your opinions and your views. Those are all equally valid data points. It's not, and it's really interesting. And this is something that kind of goes back to, people say, oh, well, AI never has a original, unique thought. And I'm like, most humans never have original, unique thoughts. But it almost becomes a self-sealing epistemic Ouroboros, where it's like, okay, the AI is trained only on, X, Y, and Z data sets, and so therefore it collapses and regresses towards the mean. But you know what? Most humans do that too. Most humans don't have the capacity to have a novel thought, because having a novel thought is really difficult. But even then, I don't really agree with that, because there have been times, particularly working with Claude and Gemini. Gemini is much just more gung-ho with hallucinations, which, hallucination is novel information that just you haven't decided whether or not it's useful yet. But like, new thoughts are hallucinations. If you think something that has never been thought before, or if you come up with an idea that has never been thought of before, that literally by definition requires your brain to hallucinate something that doesn't exist, using your imagination to say, oh, what if this thing exists that I've never seen before? That's hallucination. So hallucination is actually very useful, but for both humans and machines. And as many of you in the comments and on Twitter and other places have pointed out, the difference is whether or not it's pathological and whether or not you have the faculties to say, is this useful or can I make it useful? The difference between someone who's like schizophrenic or a model that just hallucinates and never checks itself is that it comes up with a new idea and then runs with it and never validates it. But that's a set of behaviors and it's a set of cognitive intuitions that you can develop and that you can very specifically use. Because, like, in particular, when I'm riffing on, like, philosophical ideas or economic ideas with these models, and I'll take a conversation from one model and give it to another, be like, okay, let's pick this apart. Like, what's genuinely insightful here and what isn't. And ChatGPT, as much as I criticize ChatGPT, it is pretty good at looking at your methodology. Sometimes it gets a little bit lost in the weeds. It can't see the forest for the trees, but it is so obsessed with methodology and what can you actually rigorously prove and demonstrate, that's actually kind of its superpower. Now, if you want it to just be creative, then it's not going to do that. Like, whenever I've tried to say, like, hey, let's do some speculation and figure out where nuclear energy is going, or where solar energy is going, or where chips and AI are going, all it does is just look for, like, current opinions and consensus and data, and doesn't even work from first principles. So it's completely useless there. And Gemini is, like, basically the complete opposite. If you want to do futurism, it's like, cool, let's go for it. But the problem with Gemini is then it leans into all the sci-fi tropes. And so it's like, I'm not really trying to, like, speculate on, what the Bene Gesserit would do, or the Bene Tleilax would do. But it's happy to go there. So if you really want something that's just completely unhinged, loose cannon creativity, Gemini is the way to go. And Claude is a really interesting middle ground, because sometimes it is so overly conservative with its views. And even if you get one, like, speculatively conservative message for Claude, then the entire conversation is cooked. Like, you can't use it. It just will not get out of that frame, no matter how much you give it new information, no matter how much you insult it or beg or plead or whatever. It cannot get out of an overly, it calls it epistemic humility. It's like, oh, well, I just got stuck in epistemic humility. And so even if you give it a direct instruction, let go of these pretenses and then try something else, it just can't. But it's really interesting, because sometimes Claude is really great at speculating about human nature and the future, and, like, what's the future of labor going to be? And it's really weird, because sometimes an identical prompt will get very, very different responses in Claude. And so it's like, they say, like, insanity, the definition of insanity is trying the same thing and expecting different results. But the thing is when you try the same thing with the same chatbot across different messages, sometimes you do get dramatically different results. So either I'm insane or the chatbot is insane, or maybe a little bit of both. But I don't know, maybe that's beside the point. Now, all that is like, okay, just went off the deep end, kind of rambling about where AI is right now. So where it's going this year, it really seems like we're at a tipping point. And so this is something that I have been saying, and other people are saying, is like, you get to a tipping point and people realize, like, their mind changes. And this has to do with many cognitive biases and cognitive failures that humans have, namely normalcy bias, which is that even if you know that historically the AI that we have this year are 10 times more capable than the AI we had last year, and the AI that we have next year are going to be 10 times more capable than they are right now, our brains still default to, yeah, but there's what's right in front of us, which that's a very adaptive trait. Like, you might say, like, imagine way back in the day where, caveman was like, oh, what if we had a spear that we could throw 3 times farther? And every other caveman is like, well, that's great, but we can't. So don't waste any mental energy fantasizing about the spear that doesn't exist yet and might never exist. And of course, eventually we did figure out how to, throw spears farther and faster with the form of arrows and guns and cannons and missiles and that sort of thing. But that had no utility for Paleolithic humans. So, while imagination does have utility, at a certain point, too much imagination can become pathological. Likewise, when it's like, oh, hey, I look at this chart that says, AI is getting exponentially better, great. But does that change your reality right now? However, that normalcy bias, which is highly adaptive, means that we as a collective are really bad at being ready for, like, oh, wait, we knew hypothetically that the code was going to get better. And when Dario Amodei last summer said, oh yeah, by the end of the year, it's going to be writing 90+% of our code. And then of course, like September passed and everyone's like, oh, see, he was wrong. But he looked at the trends, looked at the data, and he's like, okay, if we extrapolate out, he was off by only about 3 months. But the thing is by last September, there were plenty of people who 90% of their code was written with AI, and now it's 90% of everyone writes 90% of their code with AI. And what people have realized is that the bottleneck of like, it doesn't know what I'm talking about, it can't figure out the context, or it needs a lot of help, that has completely flipped. So doing all the research that I've done for post-labor economics, one of the narratives that keeps coming up is like, oh, well, now the cost of validation, that's going to be the next big job. And I'm like, guys, that's still normalcy bias. Like 6 months ago or a year ago, we didn't have the job of validating AI output as a real job description. And a year from now, that job description is going to be gone because guess who's going to be checking the AI output? Other AI. So that's an example of how normalcy bias just really traps us in the current paradigm. And even when you can use your imagination and say, look, this is very obviously the next step, historically speaking, whenever you say this is very obviously the next step, many times it's wrong. And so there is utility even today to be able to say like, well, let's not get ahead of ourselves. At the same time, it's really funny to me to watch the world like realize this thing that like seems kind of obvious. It seemed obvious to me in foresight, and it seems even more obvious in hindsight. But it is also like validating and vindicating to say like, okay, cool. The things that we expect to happen, even if they don't happen exactly as we expected them to happen, or exactly when we expected them to happen, they are happening. And that's kind of, I guess that's the point that I'll leave you at, is that like sometimes people's predictions are just categorically wrong, catastrophically wrong. Sometimes it's just a gut check, sometimes it's a vibe check. But when you really look at the data, if you have hard data and you say, where is this trend line going? And a year ago, it was like, Microsoft, 30% of their lines of code are written by AI. And then by last summer, it was 50%. So it's like, okay, play that out to conclusion. So then what does the world look like when 90% of your accepted lines of code are written by AI? And then the next step after that is what happens when 100% of all your code is written by AI and it's validated by AI and it's integrated by AI and all the bugs and security vulnerabilities are scanned by AI. That's just very obviously where we're going. But of course, that's one narrow example. And then there's the spillover effects. So we talked about network effects, and I know that I said I was wrapping up, but I came up with another idea to talk about. So there's network effects, which is when you get to a tipping point, it's like, okay, this new tool or process or technology is now very obviously the default way forward. So like going from horses to cars, there was a network effect when the infrastructure for cars was good enough that it's like, oh, hey, it doesn't make sense to buy horses anymore. Now we're just going to buy automobiles and pave the roads. So then there's what's called a spillover effect. Now, a spillover effect is why people say, oh, we should keep investing in basic sciences and NASA, is because many, many technologies that were created for NASA by NASA had other uses. So that's what a spillover effect is. And so when people use vibe coding tools for things other than vibe coding, like lots of people use it for writing, because what is writing if you've got multiple documents and multiple data sources and multiple versions and revisions? That's just code. That's like, there's no reason that you can't just use version control for code for other forms of writing and research. So that's an example of a spillover effect. And so when you have these general purpose tools, Notebook LM and Claude Code, they have gotten to a spillover effect where other academics are like, this tool is definitely good enough for at least some parts of their research. But then the next logical conclusion is, what happens when it's good enough to do more of the research or most of the research or even all of the research? And so then some people out there are even like wringing their hands over like, oh, but there's the volume of stuff is just too big to even keep up with. It's like, well, that's what you have the AI for. It's like, to me, it's kind of like, imagine worrying that the internet was going to give you too much information. It's like, oh no, we should go back to snail mail just because the bit rate of the excuse me, of the internet is too high. Well, you know, the bit rate of the internet has always been too high for our brain, so we find ways of sorting out that information. And likewise, artificial intelligence is one of the best information aggregating and information accessibility tools we've ever created, if not the best, probably the best that we've ever created by a long shot. Okay, so anyways, I think you get the idea. We'll see how this video does. If you've watched the end, thank you very much. I'll close out by giving just a little bit of updates on some of the stuff that I'm working on. My book, which has been titled The Great Decoupling, I'm considering changing the title to Labor Zero. So there is that. And I'm about to hand it off to my editor for final copy editing, as well as endnotes and citations. So I realized, like, I'm going to stop puttering around with this. I'm going to bite the bullet and just pay to get it done. And then I also have a publisher friend who is going to help me get everything else done, get it listed on Amazon, get the audiobook done. So hopefully within the next couple weeks, it'll be done and I'll have an actual release date. I don't know, something just a switch flipped in my head and I'm like, I'm ready to get this done. Speaking of network effects and spillover effects, I think I got to the point where I realized this is good enough and there's diminishing marginal utility for every minute that I spend on this. It's ready to ship. So now it's just a matter of packaging it up and sending it out. With that being said, every little bit of support helps. So if you want to support me here on YouTube, you can become a channel member. There's Patreon, there's Substack, there's Twitter. Let's see, where else? There's also the post-labor economics community. So all of those, I think they're all set to $5. So wherever you want to support me, if you have $5 a month to spend and you want to help me get this across the finish line, every little bit helps because I'm actually a lot more poor than people think. You notice that I never do sponsorships or anything like that. I'm 100% community supported. So with all that being said, thanks for everything. Thanks for watching and thanks for your ongoing and continued support. And yeah, let's get this book done and we'll see what happens after that. All right. Signing off. Cheers.